This is the 5th incline plane without friction video. The aim of this video is to consider a more challenging block on a smooth slope problem. The question is, a block of mass m sits on a smooth slope that is inclined to an angle of 30 degrees. An external force of 8m is applied to the block at an angle of alpha above the line of greatest slope. The external force is applied at such an angle so as to make the block accelerate along the slope at 1.5 meters per second squared. Again, before considering the problem, let's draw this out. There's the slope and the block. The block has a mass of m and a weight of mg. The reaction force. Some force is applied at an angle of alpha above the horizontal. So if we call that force F, and then this angle in here, that's alpha degrees above the line of greatest slope. We are told that this block accelerates but not the direction. So that will take some thought. And then the question itself is calculate the two possible values of alpha. Before actually calculating them, we need to think about why there are two values. There are two angles because the force could be directed so as to accelerate the block up the slope or down the slope at 1.5 meters per second squared. So let's deal with this as if there are two cases. So case 1. Acceleration is up the slope at 1.5 meters per second squared, and then case 2, acceleration is down the slope at 1.5 meters per second squared. So let's look at case 1 first. So we'll put that into the diagram. That's 1.5. The force F, we're told the size in the problem, so that's 8m. Let's resolve along the slope. So pushing up the slope, we would have 8m cosine alpha. And then down the slope, we would need the angle, 30 degrees there, or 30 degrees there. Down the slope, we would have the component of weight. That's mg sine 30 degrees, sine because it's opposite out of the components of mg. So mg sine 30 degrees equals ma. We'll just think about 8m cos alpha a little bit harder. So if we take that out of the picture, it's like this, and the slope is like that at 30 degrees. The angle alpha sits in there. The component that we've just considered, the 8m cos alpha part, is this part here. That's 8m cos alpha. How much the 8m force acts up the slope. It also has another component where it acts into the slope. That's 8m sine alpha. Okay, so that equation, we'll bring that down, and we can take m out of the equation. So we can write 8 cos alpha minus g sine 30. Sine 30 is just 1/2, so we'll put that over 2. Acceleration is 1.5. So the only unknown there is alpha. Cos alpha is equal to 1.5 plus g over 2 all over 8. Okay, so the value of alpha is 36.869 degrees, or 36.9 degrees. Okay, that's case 1. So that's the case where this is going to accelerate up the slope. We should also consider case 2, where this ends up accelerating down the slope. So in case 2, we're going to take down the slope to be positive. So with that, mg sine 30 degrees acts down, and 8m cos alpha must be acting up, so it's negative in this case. And then that's equal to ma. Again, the m's go, and sine 30 is 1/2. So we have g over 2 minus 8 cos alpha is equal to acceleration. And we know the acceleration is 1.5 meters per second squared. It's the same value, it's just only the direction has been changed. We'll rearrange for cos alpha. So we have g over 2 plus 1.5 all over 8 equals cos alpha. And working that out, alpha is equal to 64.8 degrees. That's the end of the question.